Hey, hi everybody, and welcome back to Stats with Aaheli. This is your friend Aaheli Bhattacharya with a very new playlist of learning R from zero, right? We have already covered data types, naming rules and operators and vectors, but today's episode will be all about a set of functions that you will genuinely use constantly once you start working with real data sets, okay? Like finding unique values, filtering data based on conditions, and generating sequences or for natural numbers and everything, and pulling out random samples. These sound like very small things, but honestly, this is the toolkit that makes actual data analysis possible. Now, let's dive in what we have for our first segment. Look at here. That is unique values in a vector. Now, basically, when you're working with any data set, it's extremely important to find the unique values in a variable. What do I mean by this? Meaning that values with duplicates are removed. Now, if I show you this example, it will be much easier for you to understand. R makes this really simple with this unique function, as you can see. It gives you back the distinct set of values that actually form your data set. Now, for example, I have this x variable name and I have this vector uh, with these elements. Okay, now as you can see, one number is repeated. For example, this one is again repeated here, this two is repeated here, three are repeated. Okay, so I want to know what are the unique values. Okay, gives the unique values that form the data set. Let us first call this variable with command plus return for Mac, and for Windows it will be control plus R. All right. Okay. Now I have got my variable here. Now I need to run this function unique x. Now see, what are the unique numbers which forms this whole data set? That is 1, 2, 3, 5, and 6. All right. So this will give us the unique values that form the data set. Now we have something else which is very we can understand from here only, that there is also duplicated function which checks each value and tells you a logical statement that is true or false. It will tell you true if it is a repeat or something that already appeared earlier, and false if it is the first time that value shows up. Now you have to understand these statements. Duplicate true when it is a repeat of something, right? And duplicate false when it is not repeat of something. All right, let's do that. Let's check this duplicated function. See, okay, do not see this part. See till this much. Duplicated, I have taken the variable name x. Now it will show false. First for false. That is, this is not a duplicated value. Then again false. That means this is also not a duplicated value. False, false. Then this should be true. And you see that this is true. This is true because there is a value of 3 again before. Okay, now again true, for because again we have 2 before, and then 1 true, and then again false. Okay, so this is how the duplicated function works. Now let's come to the second segment, that is filtering with conditional statements. Now let us talk about filtering, pulling out only the values that meet a certain condition. Okay, now you have to understand this by this example. I have already called this variable. Look at this vector. This is the variable name x, and I have concatenated these numbers with the value with the function c. These are the values. Okay, now what are the conditions? Condition is that x is greater than 20. Then what does it do? Writing x is greater than 20 checks every value and gives you true or false for each. But if you actually want the values themselves, not just true or false, you wrap it inside the vector in a square bracket or the second bracket, okay, and write the variable name before. Now let us see what happens when we do only x is greater than 20. See, it is returning the logical statements. That is 1 greater than 20? It is not. Is 30 greater than 20? It is not. That is why it is false. And again, it is true here. That means it is 90 is greater than 20. 40 is again greater than 20. Minus 10 is not. 100 is again greater than 20. That is why it is true. Now, if I want the actual values, that which values are greater than 20. I do not want the logical statements. Then I will put this function, this operation in a square bracket, that is the second bracket, and I will write the variable name here. That means that I want to check which values are greater than 20 in the variable x. Let's try it. Okay. Can you see the values have come is in the output here 90, 40, and 100. Okay, as I have already written in the command. Anyway, so this is how it works. Okay, the conditional statements, filtering with conditional statements. All right. Okay, now coming to the third segment. Third segment is again, you can combine filtering with length function. Now, what is this length function doing? Length function is here to count how many values meet a condition without even needing to see the values themselves. For example, here if I used the length function, then it would show me that there are only three values which are greater than 20. Now see, I am taking a different example here. I want to know how many values are less than 10. For that, first see this part. X is less than 10, which means that it will give me the logical output, right? That the values which are less than 10 will be true and others will be false. And if I put this in a squared bracket and I put the variable name before, then I will get the numbers, the actual values which are less than 10. Now, when I get the numbers here, when I get the numbers which are less than 10, then I can count how many numbers are there by the function length. All right, so let us see if it really works. It is giving us 4 because there are four numbers which are less than 10. As you can see, 1, 3, 9, and minus 10. Okay, so this is how it works. This is how you are combining length function and this indexing and the this part, filtering part. All right, with conditional statements. Now there are more filtering examples, as you can see. Now if I want the values which are not equal to 90. Now you have already learned this function, that is not equals. Now if I put only x is not equals 90, it will give me logical output. Now if I put a x before and put this function in a squared brackets, then I will get the values which are not equals to 90. And likewise here, x is greater than equals to 100, I will get the values which are x is greater than equals to 100. Let's see that. See, these values are not equals to 90. So I have got these values. Next is which values are greater than or equals to 100. We do not have a greater than 100. We only have equals to 100, right? So we have got 100. So that is all for this filtering and this part. Just a moment. So yes, coming back to the segment 4, this is the colon operator. Now this one is pretty simple, but you will use it everywhere, so you need to learn this. That is, the colon operator writes out the natural numbers starting from an initial value to an end value. Okay. For example, here as you can see, I have written 1 colon 10, which will give me the output, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means that 1 to 10 I'm getting all the values. Okay. Let's see that. See, you have got all the values from 1 to 10. So this is the use of the colon operator. Now coming to the sequence function. This is our segment 5, and now sequence is something which is very interesting and you are going to use it of course everywhere. Just as I stated this in the beginning of the video, that whatever we are learning in this video, this is your toolkit to be used in any data analysis which you are going to do further. Okay. Okay, now coming to segment 5, this is the sequence function. The sequence function is a more flexible version of the colon operator. That is all. It will let you control the step size between the numbers. As you can see here, the general syntax I have written, that is sequence. First, we have to write in the open bracket, that is from, which means from which value I want to start, and then to, that is up till which value I want to end. Okay, and then by means what? How many gap will be there in that sequence. So now if I write sequence from equals to 0 to equals to 100 by 5, now this means what? That means I am going to write a sequence from 0 to 100 which will differ, all the values will differ each other by 5. Okay, and now I have written the same thing here to 0 105, because these, even if you do not write the from, to, and by, R already knows the general syntax, right? This is general syntax, so only if you write the numbers, it is same as before, just a shorter form of that, right? So let us see what is the output. Look at here. First, if I see the sequence from 0 to 100 by 5, you get the values 0, 5, 10, 15, 20, 25, like this up till 100, right? With the difference of 5. Now, if I want to do the same thing just as a shorter form when I write it, let us see if it works. It again works the same, okay? So I have already shown the general syntax from, to, and by. Now look at here. You can also use sequence function with a length argument. Instead of by, you can use sequence 0, from 0 to 100 and then length 100. Now when I say I have given here length 100, this spreads out exactly 100 points evenly between 0 and 100, and unlike the colon operator, this can include decimal values too. Okay, so look at here. When, see, this is the general syntax from, to, and by, but when you're using the length function, then you have to write any in the shorter form also. From and to is same, but instead of by, you need to write length is equals to 100. You just write 100, then it will not work, okay, because that is for by. Now look at here, what is the output? See, as I have told you, like instead of natural numbers, there can be decimal numbers. So this is what? Any random points including decimal. All right. Okay. This is our segment 6, the sample function, last one for today. And this was genuinely fun, okay? Sample function lets you pull a random sample from a vector. Random sample, okay? The general syntax, as you can see here, is that sample, then in the open bracket, you need to write the data. What is the data here? Data is a variable name. Whatever, even if you do not have a variable name, I mean you have not previously stated any variable, any vector, then you can already directly write the data here, and then you need to write the n. What is the data here? Data is the vector of values you are sampling from, okay? And what is the n here? N is the how many values you want in that sample. Like you have the whole data set. Now I want a sample of, say, 5. I need the sample size to be 5, so I write instead of n 5, okay? Now replace is equals to true or false. Now what does this mean? Replace decides whether sampling happens with replacement or without replacement. That means when replace is equals to true, that means it is with replacement. When replace is false, that means it is without replacement. All right, this is very much understandable, right? Next is prob is equals to null, which means probability is equals to null. This is the default value of R. Okay, when probability is equals to null, which means that each and every value is equally likely. But when you are like probability, this function is actually an optional vector of probability weights. For when you don't want every value to have an actual chance of being picked, you simply write few probability values for each data and then you run it. Okay, I will show you both examples. Now look at here. As I have shown you all these things, now look at this example. Example 1 is sampling without or with replacement. Okay, now I am taking this vector x. X is 1 to 50. That means I am having the numbers from 1 to 50, that is all natural numbers. Now I am taking the sample function x. As you can see here, in small it is written sample x size replace equals to false, prob is equals to null. When you are using the rstudio, it already gives you the syntax of it, okay? That is, false is the, again, the, the default value of R. But when you're using the R GUI, okay, that is when you're using the basic syntax of R and you're using the R editor for it, you do not have these kind of, the advantages where you get to know which function you're using and what kind of general syntax is there. So when, if you're learning R and if you're learning for your college, then you do not get to use the R studio, because of course your professors won't want that you can see all the general syntax and everything. So You can practice in R GUI, and then in our editor you write all these codes and you do it everything manually. Okay, just learn from here. Okay, so here I'm saying the x is what my data is given here, and I want the sample size to be 5, and replace is equals to false, which means without replacement. Okay, so what happens there, let us see. This is my example 1, and the variable. Now I am looking at here. See, I am saying without replacement. I do not want any kind of replacement. Okay. So what happens? There are values which are picked randomly. Okay. And next there is replace is equals to true, which means with replacement. That means I can get similar values too. Let us see. I have got similar values here, 36 and 36, as you can see. Okay. Now these are all these values are given here with equal probability, that every value has got equal probability of getting picked. Okay, I have not given any kind of probability weight here. So let us see the second example with weighted, that means non-uniform sampling. Now what does this non-uniform sampling means? This is a slightly more advanced example with probabilities which are unequal. You can see here I have given the variable names. That is, I have given here the elements a, b, c, d and na, and I have given the sample names which is my data. Okay, and 4. I want my sample to be having 4 elements. Okay, and replace is equals to false. Replace false means what? Without replacement. And probability I'm giving here, see, I'm concatenating the values because there are multiple values, right? So I have to use the C function. Now I am giving the probability that A has got 40% chance of being picked, while D and NA has only got 10% chance each. So the sampling is not uniform, it is weighted. All right, so let us see what happens here. First I have got my function, that is the names, and now I am taking this sample, the names 4 replace false, probability I am giving this chance. And here I, in my sample, I've got A, B, D and NA. So this is weighted, this is not uniform, this is not like each value has got equal probability, because I have assigned the probabilities to be like this, right? So this is how it works with non-uniform sampling and with uniform sampling. Okay, so, yes, that is all for episode 4. We have covered the unique values, filtering with conditions, the colon operator, the sequence function, and the sample function. A genuinely very practical toolkit, if you understand, and that you will use almost in every data set you touch going forward. Okay, now what you can do after this is what, try generating your own sequences and pulling random samples of your data. Okay, it's the fastest way to make this stick, whatever I have taught you. And yes, until next time, study hard, and yes, like, subscribe, and I'll catch you in the next episode where I'll be teaching matrices in R. Okay, so yes, thank you for watching, and yes, bye bye, see you soon.